The second and last video lecture on operant conditioning, on reinforcement in operant conditioning, is going to be about what makes a reinforcer reinforcing. And it may seem like a strange question to you, because if we're talking about, for instance, why food is reinforcing for a hungry animal, it seems almost obvious that food should be reinforcing for a hungry animal. But it's only obvious because the explanation of reinforcement in that case is somewhat circular. You know that food is reinforcing for a hungry animal, or rather, you know that an animal is hungry because food is reinforcing. And so explaining reinforcement of or why food is reinforcing based on the hunger in the animal, it's not really adequate, because the only way you can explain the hunger, or the only way that you can detect the hunger in the animal, is by evaluating how reinforcing food is in the first place. So that is not very satisfactory. And besides, there are many situations in which reinforcement is not nearly as obvious. For instance, many of us play puzzles, or video games, or watch TV. There's no particular biological need, like in the case of food, for instance, for a hungry animal, that will explain why we watch video games, or we play video games or watch TV. Yet, those are relatively, important reinforcing stimuli. So, how do we establish that something is a reinforcer? And how do reinforcers work? Early theories of reinforcement, of course, invoked sort of like a biological homeostasis, that is a biological equilibrium, that we need to have a certain level of nutrients, and if we are low in a nutrient, whatever allows us to obtain that nutrient will be reinforced by the obtention, or by the securing that nutrient. But as I showed you just with my example of the TV and the video games, that is can easily be readily dismissed as an explanation for every possible reinforcing situation. Instead, David Premack came up with, back in the 60s, with an interesting behavioral theory of reinforcement, one that does not invoke biological necessity, biological need, to establish what may work as a reinforcer. And this idea is known as the Premack principle. The idea is the following. Suppose that you divide your time. Let's say all your time in a day is contained within this circle, and you draw a pie chart in which you indicate how much time you spend doing various different activities, right? For simplicity, we're going to assume that you only do a couple of things, that you only do two things. You either play or you study. And as this pie chart shows, you don't study as much as you play. Now, this is under a situation in which you have no constraints. It's an important thing. So this is a distribution of your time when there is no constraints to what you can do. You can do whatever you want. I give you a whole day where you can do whatever you feel like doing. And during that day, you spend this much time playing and only this little time studying. Now, the Premack principle would say that the behavior that you spend more time engaged in, like in this case play, may serve as a reinforcer for other behaviors that you spend less time engaged in, like studying. So if I want to increase the amount of studying, let's say, um, if instead of getting this distribution, I wanted you to rather study this much and play this much, what I need to do for that to happen is to make playing contingent on studying. That is, if you study, as a consequence of studying, you may be able to play. I will need to have control over your environment to restrict your access to playing, and so I can use it as a reinforcer. And this is what this is simply what Premack principle says, that a behavior that an organism engages in for a relatively large time may serve a large amount of time may serve as a reinforcer for a behavior in which the animal is engaged for a shorter amount of time. All right. So notice that this has a few implications. One of them is that the reinforcer is no longer a stimulus, but rather it's an activity. It's another behavior. So we're not talking about food as a reinforcer, but rather we're talking about playing, watching TV, engaging in some activity. Instead of food, we're talking about eating, and so on. And so what is reinforced and what is reinforcement, or what is a reinforcer, are rather, interchangeable. In fact, Premack demonstrated this with a neat experiment in which, remember, this was back in the 60s, so kids at that time really enjoyed playing pinball. And they were given a choice between eating candy and playing pinball machine. That was the choice. Now they could spend, these kids could spend as much time as they wanted playing pinball or eating candy. What Premack did was track how much time they spent doing each of these two activities. So he found that some kids spent most of the time eating candy and a little bit of time playing pinball. And other kids, they spend most of the time playing pinball and a little bit of time eating candy. So so we're gonna call these kids the eaters because they like to eat candy, and these kids the players because they like to play pinball. Right? And so what Premack found was that he could change in the eaters, he could reinforce pinball playing by making candy contingent on playing pinball for a certain amount of time. So for these kids, if he asked the kids to play a minimum amount of pinball to get some candy, he was able to increase the amount of pinball that the eaters would play. And the opposite was true with the players. If Premack was able to increase the amount of candy that his kids will eat by making access to the pinball machine contingent on the amount of time they spent eating candy. That way he increased the amount of candy that they ate. So you can see how this also works in the how this works in with a rat pressing a lever in a Skinner box. So if you look at how much, if you leave a rat inside a Skinner box that is furnished with a lever, and you look at how much, and you give the animal free access to food, and this is a hungry animal, what you would see is that a little bit of time here, there's very little time that the animal is going to spend pressing the lever, and most of the time the animal is going to spend it eating food, the free food that you're allowing the animal to have for free. So Premack would say that this is the reason why you can reinforce lever pressing in a hungry animal with food, because if you had left the animal to eat food freely or to press lever freely, it would have spent most of the time eating food and very little time pressing the lever. And following Premack's principle, a response or a behavior that it's the animal engages in more time for more time should work as a reinforcer for another behavior that in which the animal is engaged for a shorter amount of time. The response deprivation hypothesis is very similar to Premack's principle, but it adds an important component. And whereas Premack's principle indicates that a more prevalent response may serve as a reinforcer, a more prevalent behavior may serve as a reinforcer for a less prevalent behavior, response deprivation hypothesis suggests that that may not necessarily be the case. That if you have a particular distribution of behavior, let's say behavior A and behavior B, we're going to keep it relatively abstract, and behavior A is far more prevalent than behavior B. The Premack principle would say that A may serve as a reinforcer for B, but B cannot serve as a reinforcer for A. The response deprivation hypothesis says that yes, it may serve actually, that B may serve as a reinforcer for A. If to be able to maintain this level of engagement in B, you need to do more A, it is possible that that constraint may make A even more prevalent. The best way of looking at this is in a graph, or rather in through what's called by identify what's called the behavioral bliss point. Let me show you what this is, and let's illustrate it with a concrete example. So you probably have seen this already, in which we have two behaviors, one in the y-axis, one in the x-axis, and so we're going to say that this one is eating and this one is playing. So you're observing a child for I don't know, let's say for 10 minutes, and those 10 minutes the kid had free access to games that he could play with, and he had free access also to food that he could eat. And what you observe is that during those 10 minutes, kids spend 1 minute eating and 1, 2, 3, 4, 5, 6, 7, 8, 9 minutes playing. So this is the bliss point, will be at the intersection of these two numbers: 1 minute eating, 9 minutes playing. This is your behavioral bliss point. This is the distribution of behavior for this kid if there are no constraints to it. Now let's suppose that you impose a constraint on this particular kid, and the constraint corresponds to, it's what's called, oh, that looks terrible, it's a one-to-one constraint. That is that for each minute eaten, of the kid has to spend 1 minute playing. Notice that if you impose that constraint, there is no way for the kid to maintain its bliss point, because the kid wants to would without that constraint spend 9 minutes, 9 more times playing than eating. So what's going to happen when you force the kid to choose between various different distributions, but that all involve a one-to-one relationship between eating and playing? The kid could spend just 1 minute eating and 1 minute playing, or 9 minutes eating and 9 minutes playing, or anything in between 5 and 5, and so on. Think about what could happen. Think about what will happen if, for instance, playing was really important for this kid. If that is the case, then you would expect that the kid will spend, when you give all these different alternatives to this kid, the kid will maintain eating, playing for 9 minutes, but may actually increase eating to 9 minutes. So you if that were the case, you would have increased eating from 1 minute to 9 minutes. So you effectively reinforced eating. You increased the frequency with which eating occurred. Another extreme consequence may be that that you reduce the amount of playing. So if the kid really doesn't want to eat more than 1 minute, what you may see is the kid only spends also 1 minute playing. And so as a consequence of this, you reduce the amount of playing. Right? And most likely what you will observe is somewhere in between. Maybe somewhere like here. It's a likely outcome in which you get some reinforcement of eating. Let's say this may be 5-5, 5 minutes playing, 5 minutes eating, and that means that eating increased from 1 to 5 minutes. That was reinforced, and playing was reduced from 9 minutes to 5 minutes. All right. So now let me. So that all of this is very consistent with Premack's principle. That is, that you can use playing as a reinforcer for eating, and typically this is what you would observe. If you observe that you get a switch in the distribution, goes from the bliss point to here, what you're getting is an increase in eating and a decrease in playing. But suppose you set up a different schedule. Let's see. So, this is your bliss point. So suppose that now your schedule looks something more extreme. Like, let's say, like this. It passes close to the bliss point, but you can't quite get the bliss point. Let me draw a little bit more extreme to illustrate my point. There you go. Something like this. So the kid has to, in this case, to get 1 minute of eating, it has to, let's say, it has to play for 12 minutes. Again, so we went in the previous schedule, we forced the kid to eat for 1 minute for each minute that it was playing. So we constrained the different options the kid had, and now he could choose between how much eating and playing he wanted to engage in, but it had to be the same amount for eating and playing. Now in this example, we are introducing a very different constraint in which the kid really has to play a lot more than would normally do in order to get the same amount of eating. And so in this case, you can think about what are the extreme possibilities. One extreme possibility is that the kid really doesn't want to play more than 9 minutes. In that case, you will get an allocation that will fall somewhere in here. So you'll get a reduction in eating. Kid will not eat as much. The other possibility, other extreme possibility, is of course that that you actually get, I don't know what this, there you go, that you actually get an increase in playing. So if eating is really important for the kid, if it wants to keep its 1 minute of eating, right? And in this case, notice something. If that were the case, that would mean that you were able to reinforce eating. I'm sorry, you were able to reinforce playing by making it eating contingent on playing on a very particular schedule. And this is, if you notice, inconsistent with Premack's principle. Premack principle says that, in this example, would say that only playing can reinforce eating, but eating should not be able to reinforce playing. And in this case, we're showing that by constraining eating to playing in a particular way, we're able to reinforce playing, to increase playing from 9 to 12 minutes. Most likely that the allocation of behavior for this kid is going to be somewhere in the middle, maybe closer to 10, 10 and a half, 11 minutes, and a little bit of a reduction in eating. But in any case, 10, 11 minutes of playing is more than 9. You've got an increase in playing, and thus playing was reinforced.